Hey everyone. In the next 4 minutes, I'll show you how to supercharge your scientific research analysis using ontologies with cognee. If you're analyzing medical papers, research documents, or any scientific literature, you'll learn how to automatically discover and visualize hidden connections in your data. If you ever tried analyzing multiple scientific papers, you know how challenging it can be to connect related concepts across different documents. Traditional search methods treat each paper as an isolated document, missing the valuable relationship between medical concepts, symptoms, and treatments. Here is where Cognee's ontology-powered approach comes in. By using ontologies, which are formal representations of domain knowledge, we can automatically identify connections, standardize terminology, and enable more intelligent querying through knowledge graphs. Let's try. So first, we'll try to set up Cognee. We'll dive into the code and set up our environment. So with pip install cognee, you can get started. You'll need Python 3.8 and later with an OpenAI key. If you're following along, open up the notebook linked in the description. I already have it installed, so I'll skip this step. Let's import the necessary libraries. I'll pause here so you can see the imports we need. Let's create the pipeline. We will create our knowledge pipeline. This pipeline does 3 important things. It cleans the existing data, processes our scientific papers, and applies ontologies to create connections. The key here is our cognify function. It can take an optional ontology file. We run both with ontology and without ontology to see the differences. So let's run the pipeline. Here it's where it gets interesting. So let's query our processed papers with some medical questions. We'll ask about risk factor for type 2 diabetes, preventative measures for hypertension, symptoms of cardiovascular diseases. And now watch how responses will change in the 2 different versions. So after running the pipeline, we'll see that the version with ontology has detailed explanations of symptoms for possible cardiovascular diseases. It has diseases associated with obesity and many other things. Results with our ontology will be, simpler. Symptoms will not include as many details, nor will it actually have the information about the cardiovascular diseases. Preventative measures will be broad, so we'll not have as much quality as we did with the ontology. One of the most powerful features of the tool is the knowledge graph visualization. With just 2 lines of code, we can create an interactive visualization of all connections of our system. Each node represents a concept, and each edge shows a relationship between the concepts. Here, we can see that effectively we have related ontologies and concepts automatically connected. We have terminology that standardizes across the papers, and we have a system that can infer relationships even when they are not explicitly stated. Without ontology, we miss a lot of connections and insights. So here, you can see the participants age 20 and above, the diet, cardiovascular diseases, nutrients, and all of this information now that has been connected as we imagined. So practical applications of this approach include medical research analysis, drug discovery, clinical decision support, academic literature review, and any field where understanding connections between concepts is crucial. That's it. You've just learned how to enhance your scientific research analysis using ontologies with Cognee. Check out our Jupyter notebook in the description to try it yourself. Join our Discord community for support, and don't forget to like and subscribe for more tutorials.